Welcome everyone. Welcome back to Omega Statistics. Today we are doing a full tutorial on linear regression and multivariate regression. First we need to import our data. Today we are going to be using the Stata example data sets. So we're going to click File, Example Data Sets, installed with Stata, and we're going to scroll down to the NLSW88. That's the National Longitudinal Survey of Women from 1988. Click Use, and we're also going to open up a new do file. So we're going to click on that little notepad icon and it'll pop up a new do file, and we're ready to get started. So we have this data and here are the variables, but I always like to summarize the data before we begin, just to give me a sense of how many observations there are, what are the means and standard deviations. We have a participant ID code, age, race, ethnicity, so that's coded as white, black, or other, married, yes, no, or never married, grade completed, so that's how many years of education completed, college graduate, are you a college graduate, yes or no, do you live in the South, SMSA, the city, the industry your occupation is in, whether you're union or non-union, what your wages, how many hours you work every week, and your tenure, how long you have been at that job. So this is our data, and we are going to begin by first looking at a scatter plot of the data to see how the data are related. So we're going to go to Graphics, Two-Way, and we're going to create a plot. Basic plots, scatter is the default, and our Y variable is going to be wages. I want to see what affects how much wages you earn based on your grade. What's your highest grade completed in school? I'm going to sort on the X variable, hit accept, hit OK, and it'll give us a scatter plot. So we can see here's the current grade all the way up to 18 and your hourly wages. And we have some outliers up here. We have some really high earners for less education. But in general, it looks like we're going to have a linear regression in a positive direction. That's great. So to do a regression, all you have to do is type regress as the command, your Y variable, which is wage, and your X variable, which is grade, and hit enter. So here's what Stata gives you in the output. Here's your model and your residual, sum of squares, degrees of freedom, and your mean squares. This is your ANOVA table. You have your number of observations, your F statistic, the probability of your F statistic being significant, your R squared and your adjusted R squared, and your root mean squared. Right now, because there's only one predictor, grade, the R squared and the adjusted R squared are going to be the same. But when we start adding variables for our multivariate regression, we're going to be using the adjusted R squared. And then down here we have a coefficients table. This is our Y variable, which is wage. Here's your predictor, which is grade. And this constant is the intercept of the slope, which is also significant, as you can see by the p-value. So here's our beta coefficient. This is unstandardized. So for every 1 unit increase in grade, there's a 0.74 unit increase in wages with a standard error of 0.045. This is your T statistic, which is the ratio of your coefficient and your standard error, and that'll give you a p-value if you look up your p-values on a table. The confidence interval gives you an upper-lower bound that we are 95% confident that the coefficient lies between 0.65 and 0.83. So we can see that this is a significant predictor of wages. Now, there are other things in our data set over here, such as age, race, and whether you live in the South or not, that may or may not predict wages. So we are going to do a multivariate regression with those extra variables. And it's very simple. It's just like the linear regression. So we're going to type regress. Our predictor, our Y variable is wage. One of our predictors is grade. We're going to include age and race and South. Now, If you notice that race only gives us one coefficient, that is because it lumped together race as a control variable. Now, if you wanted to look at race separated out by black and other, you're going to have to use the I. So I dot. So we're going to do it again. We're going to type regress. Our wages is our Y variable, and our predictors, grade, age. We're going to do I dot race, which will list out the individual values for race and south. And now, as you can see, there's black and other. White is omitted as the reference group, so when you interpret these coefficients here, you're going to interpret them in relation to the reference group, which is white. You can see that grade, the coefficient has changed in effect, slightly decreased, but it's still 0.71, so looks like grade is a strong predictor. Also, you can see by the p-value that south is a significant predictor. So living in the south results in less wages over time with a standard error of 0.24. Race, either being black or being other, is not a significant predictor for worse outcomes, and neither is having older age. It's neither beneficial nor detrimental. And that is how you do multivariate regression. You can see our R squared is 0.12, and so this model with our predictors in it accounts for about 12% of the variation explained in wages. So there's something else that explains the variation in wages, but this is still pretty good by a social science model. Thank you for attending this tutorial. If you have any questions or comments, put them below. If you like this, give this a thumbs up and subscribe to my channel for more tutorials on Stata. I will see you later.